Hello out there. Welcome to calculus. Nothing more exciting than that. Were we okay on this part?
Yeah.
This is like almost too much, right?
Yep.
Okay. Sorry about that. I got a little carried away. How about this? Was this okay?
Yeah.
Okay. This is a part that you might have struggled a little bit. So what shapes were they? Parabolas, correct? And then it says, why were they parabolas? Because the antiderivative to 2x is x squared plus c. That's it. Okay. So then they're asking you for a particular solution. I have this, y equals x squared plus c. So they give you this point, right, Nathan? Okay, so what do I do to figure out c?
Plug in 1 for x and 2 for y.
And you get 1 for c. And you get y equals x squared plus 1. And you're done. Okay, so again, that hopefully that wasn't too bad. Okay. Again, another chart. Right? And then you had this, correct? The difference between this was dy equals 2y. Over here, we have, this was dy equals dy dx is equal to 2x, correct? Now on these, as you went and looked vertically, all these segments should be parallel to each other, correct? Because x is the same as you go up or down. So over here, when you graph these, they should have looked the same going this way. Am I correct? So right here it says generalize the relationship of the segments in your two slope fields. In other words, what would you expect if your differential equation was in terms of x? Well, I would expect segments that were parallel vertically. And how does this differ compared to the differential equation in terms of y? In terms of y, they are parallel horizontally. Does everybody follow that? And I'll get to where I use that in a bit. So again, in terms of x, they're going to be parallel vertically, and in terms of y, they're going to be parallel horizontally. Yes, ma'am?
What does the graph look like?
This?
Yeah.
I don't know. I think it looks like this, actually. What did you get? You must have had 0 here, am I correct?
Yeah.
And then right here you would have had 2. And right here you would have had 4. And here you would have had, they get really steep right here, correct? Somehow you're supposed to draw 12, which you can't do. It only goes up to 4?
Well, only goes to y equals 2.
Because it's y.
Isn't it dy dx equals 2y?
Yeah.
Isn't y 12 here?
Well, yeah, but we didn't have to. That was.
You didn't have to graph it?
That wasn't on the.
Oh, okay.
That wasn't
On the chart above, it doesn't
All right.
go to that high.
Okay. Okay. But I could have done it, right?
Yeah.
Okay. I got you now. So this should have been parallel. This should be parallel like this. These should all be slopes of 2, correct?
Yeah.
Then these should all be slopes of 4 or something steeper. And then these are even steeper. I don't know, do we go up to 3?
No, that's it. I meant the points on the back. We're not there yet, so it's fine.
Yeah, I'll get to there.
Yeah.
Okay. And then this should have been a negative 2, correct? So it goes like this. All right. Okay, can I switch to the next page? Okay, so it asks me to sketch two particular solutions through 0, 2, and through 0, negative 3, correct? All right, and that's your question. Okay, so 0, 2, so this one would be like this, correct? Right? And you might even had this all the way along there, I don't know. So I would say it looks something like that. Okay? And then 0, negative 3, is that correct? Was that the next one? And I'm not going to draw them all in there, but I think you should get something that looks like this. Would you agree?
Yep.
Something in that fashion. Okay. What I don't want to see is like a straight line or something going against what I call the grain. Does that kind of make sense? You shouldn't be crossing those segments because they're tangent lines. All right? So, to come up with the equation. All right? So this is an example. This part right here, if you were able to draw this successfully, that's 3 points on the AP exam. Here's the rest of the 6 points. All right? And you'll see this, and you may or may not be confused at a part, but we're going to be doing this process tomorrow and then again on Tuesday. Right? Because I'm thinking tomorrow we'll start 6-2 and hopefully I won't have to talk anymore on Monday and I can give you some time to work. That's always my goal. So here's the equation. I have dy dx is equal to 2y. So what I'm going to do is I'm going to do a process that's called separating the variables. They are not separated right now because this y needs to be over here by the dy. And the way I'm going to do that is I'm going to do it by division. So I'm going to have 1 over y dy equals 2 dx. I did not bring the 2 over here because my goal, if I can, is to get y by itself totally. I want an equation that's y equal to something. This right here, if I get to this place successfully, if you can do no more than this, you have 3 to 4 points. Okay? That's how that works. Now, if I would have had x plus y, and I have that is equal to dy dx, you cannot move the y over here by subtraction. Because what happens if I multiply both sides by dx, I get this. This quantity and this dx are being multiplied, correct? I can't subtract y now, can I? And if I distribute it, I'd have 2 dx's. It gets worse. So when we have something like this, we have a derivative in which we cannot find the antiderivative. You can always find derivatives. You can't always find antiderivatives. So what we have, and this is what we learned in BC Calc, is something called Euler's method, in which we can approximate what that antiderivative is. All right? Likewise, if I had something like this, I cannot move it to this side for addition, because I'd have the same type of situation, correct? You can only move y by multiplication. So if I had this, I could multiply both sides by y and multiply both sides by dx, can't I? So I can multiply and divide y. I cannot add and subtract y to move it. You'll hear me say that over again. So we're okay up to here, correct? So now what I'm going to do is I'm going to integrate both sides. The antiderivative to this is 2x plus c. The antiderivative of this, does anybody have an idea? I think I'm hearing natural log. If you're saying natural log, you're saying the right thing. It's going to be the natural log of y. Now, Tristan, you guys know Tristan? He said, Mr. Kruger, aren't you really supposed to have a plus c here and a plus c over here? And I said, yeah, but they're not the same c, so I'll call that c1 and c2. And then, since I want to get y by itself, I would subtract c1 from c2. c2 is a constant. c1 is a constant. When you subtract a constant from a constant, you get a constant. So we just write this form. I skip this and go to here. To me, it's like a little bit of overkill. Does that kind of make sense? I'm just going to have the one constant. Now, when we start reviewing and you'll start seeing the answer key to these, they'll do the C1, the C1 and the C2. But if you see the student work, they'll write it like this and get full credit for it. Does that make sense? All right. So my next step is to rewrite it like this. This logarithm has a base of e. That's the exponent. That's the answer you get when you take e to that power. Are we all right there? Okay. This is going to become this. Because when you add exponents, you're multiplying terms that have the same base. Are we okay with going from here to here? Because I do not want to go too fast. So Matt, E is a constant.
Yep.
I'm raising it to a constant power. I don't know what that power is, but I know I'm going to get what as an answer?
A constant.
A constant. So what we do is we say that e to the c is going to be a constant that I'm going to call b. And so now my equation is this. Y equals b e to the 2x. It is some constant that is created by taking e to some power. All right? So this, now I want to come up with a particular solution. I'm going to substitute 2 in for y and 0 in for x. So I'm going to have 2 equals b times e to the 2 times 0 power. 2 times 0 is? E to the 0 is? So 2 is equal to b. So what is the equation of my graph? It is y equals 2e to the 2x. If you get to here, you have a total of 9 points. Yes, ma'am.
So you don't plug the 2 into the c anymore. It's just 2 is b. Because you know how e to the c
Correct. So it means e to some power gives me 2.
Oh, okay. That makes sense.
And since that'd be kind of an icky number, you know what I mean? And the 2 is very important because if you look at an exponential equation, it crosses the y-axis, right? It crosses the y-axis where an x is 0. So this is the y-intercept. So it's better to know the y-intercept than to know what that c is. Yes?
What happened to the B?
It was replaced with a 2
Well, why?
because when I put 0 in for x and solve for b, it's 2. Because y is 2.
Oh, because yeah, but wouldn't it be y equals, how do you plug, I get the, if you're plugging it into the y equals b times e to the x. Oh. Okay, I see it.
You sure?
I see it.
I'm going to do it again here in a
I
second.
see it now.
Okay, and then I'm going to graph it, okay? So, this is what here's my general equation, right? And now I got -3 for y. B equals e to the 2 times 0. Well, that means b is going to be a -3. And that's my specific equation. All right. So I'm going to come to my phone. And this is what you got to give yourself a little bit of time. We're going to be looking at this right up until the test. So this won't be the last time you see this. Let's see here. So let me type in Slopefield. To y, and let's have 15. Of course, I typed in 16. So that's kind of what your Slopefield looks like. Would you agree? Okay. And then I'm going to put in y equals 2e to x. So there's that graph. There you can see it's going through that point 0, 2. You see how it fits in there? I'll put in the other one. Y equals -3e -2x. Oh, I did that wrong, didn't I? X. There we go. See how it looks like that? So the negative is underneath the y-axis. The positive is above it. All right? Okay. So that takes care of that sheet. I think it's worthwhile going through these. Were we okay with this? I think we did this in class. Did we do this whole front page in the class? Except for the last one? Well, you should now know which one that is. It's B, correct? Right. This one, I'm going to look at number 7. Number 7 is in terms of y, correct? So the segments should all be parallel horizontally. So if I take a look at number 5 here, look at these going across. They're all the same. Do you see that? So number 7 should be A. Here's another way I know. The slopes are always positive, aren't they? Aren't those slopes all positive? Don't they point up towards the right? Did I talk about these other ones already? Number 8, when x and y are positive, the slopes are positive. When x and y are both negative, the slopes are positive. Would you agree? And when one of them is negative and one of them is positive, it's negative. So if I take a look here, and let's say I chose this one, they're positive here, but they're negative here, aren't they? They should be positive. If I look at this, they're positive here, and they're positive here. They're negative here, and they're negative here. So H should be D. Are we okay on that? Do I need to talk about this anymore? All right, next page. This should have been okay, right? Remember, 2 to 3 points. Yes?
Well, if you're going to go through all of them, because it's
I'm going to go to the back one.
Oh, okay, it's on the third one.
Yeah.
So,
Oh, this one here.
yep. Yeah. Okay, so where x is 0,
Yep,
it would be undefined, right?
correct.
So do you draw the asymptote on the slope field?
I mean the vertical tangent line that it could have.
So it's not an asymptote.
It may, right, and because it could be, when we take a look and we define the purpose of the derivative is to say that where it is 0, I have a critical number, and I may have a horizontal or I may have a vertical asymptote, correct? Not a tangent line, not asymptote, but tangent line, correct? So if this was 0, it could be a sharp point, correct? So I get really, what I have noticed on the AP exam, when the denominators, they don't put values of 0, they don't put segments at 0 with what's in the denominator. So I have never seen a vertical one, though I've noticed on my phone it'll make one. Okay? That's it. That's the only thing, correct? All right. So if you want to turn those in now, that'd be okay. So now you are, except for the thing that's online, that you can submit to me online, that's your last homework for 6-1, right? Okay. My goal always is, it's always hard when I go over a test to get all the notes done, especially on a connections day. But my intent always is have the second day be a work day. And I really think tomorrow I will be able to get done with at least 80% of the notes. You got it. All right, so let's take out the notes and go through those. Okay, are we okay with this? Can you see that's the parabola? If you took the antiderivative, it would be 1/2 x squared plus c, right? And you should be able right now on this one say, all right, if I'm here. Now, it doesn't have to be perfect, and mine in no way are perfect. I just try to find a guideline to fill. You don't want to be going this way. And I'm saying that now because 30% of the students were going like I don't know. I couldn't figure out how they could do that. But it doesn't have to be perfect. It has to give the general idea of what it is. So if I flip over to the next page, here's this one, and we've already done that one. That's e to some power, correct? And you can kind of see that goes like this. Goes somewhere like this. Here's one that we can't figure out the antiderivative to, but it kind of looks like to me that it goes something like and it doesn't, see how you have this dashed line right here? It doesn't cross that, does it? And I could see that it's getting really, really close to there. So that would be a curve I would have. Let's see if I can come up with another one. Perhaps something like that. So here's another form of a differential equation. Do you notice that it's embedded in the computation? It's having 2y added to it. It's still a differential equation because there's a derivative in the equation. This is called a first order derivative because you have the first derivative. This is called a second order derivative because you have the second derivative. Both of these are differential equations because they contain derivatives. So if I had a third derivative, it would be a third order derivative. Next page. So you may be asked to verify a differential equation with its general solution. So it says, how do I, and it says, all right, do that. Do that by substitution. So what I'm going to do is I'm going to start out, write down y equals c e to the negative 2x. And I'm going to figure out what y prime is. And would you agree that I get a negative 2 c e to the negative 2x? You get e to the negative 2x, and then you got to take the derivative of negative 2x, and you get a negative 2. Now, I know a negative 2 is a constant, and I know c is a constant. And I know when I multiply them together, I would get a constant. But with verification, I'm going to leave it just like this. And I know it's verification because it asked me to verify it. So now I'm going to come in here and do substitution. I'm going to write this equation. I'm going to write a negative 2c e to the negative 2x plus I'm going to multiply y by 2. It says add 2y to it. Well, I get 2c e to the negative 2x. When you add those together, what do you get? You got to get 0 because they're opposites. You're done with your verification. I am now given a general equation. Here's a second order differential equation. I'm going to verify that they're connected. How am I going to do that? Well, I'm going to take the what derivative first? The first derivative. And S prime is going to be what, Jacob Weber?
Be negative 32t plus c1.
What happened to C2?
It's gone.
It's gone, right? So now I'm going to take the second derivative. And Kate, what am I going to get?
Negative 32.
Negative 32. Is that what I want? I've just verified it. I'm done. You're going, man, is it this easy? Yeah. Till you start doing separation of variables and you got natural logs to deal with. But you've seen one, right? You're going to see another one soon. And remember, you don't have, I don't want this. I don't know how to do that problem, I'm not going to do it and get 0 points. You can do some portion of it and get points. And they'll give you points for every one you get correct. And you're not going to be perfect on the AP test. You won't be. So you perfectionists, you got to get used to that. Anybody get perfect? Anybody take AP juniors? If you take geography, AP geography? What? AP World History? How many of you got perfect on that one? Okay, just thought I'd ask. Okay. All right, so I'm going to verify. I'm going to verify that this differential equation, or excuse me, this general solution is connected to this differential equation. So I'm going to do that by taking the derivative. And I'm going to use y prime instead of dy dx. Are you okay with that? Okay, so Isabel, can you take the derivative of y squared for me? 2y times what? Every time I take the derivative of y, I've got to multiply it by y prime. Okay? Minus Logan Hackett, what's the derivative of the ln of y?
-2 dy.
I'm going to have y prime, right? But what's the derivative of the ln of y?
Well, 1 over y.
Yeah, 1 over y, perfect, times y prime. Are you okay? All right. And then Maria, the derivative of x squared? 2x. So I'm going to factor out a y prime, and I get y prime times 2y minus 2 over y equals 2x. Remember, my goal is to get it to look like this. So anytime I have a fraction, I get a common denominator. And my common denominator is, this is over 1. And so then my common denominator is what? Y. So I'm going to multiply this by y, and I'm going to multiply that by y, and that's going to become y squared, correct? So now I have y prime, and I have 2y squared minus 2 over y equals 2x. I don't know how you were taught. When I showed students how to solve equations with fractions, I always had them multiply by the reciprocal. So that's what I'm going to do here, is I'm going to multiply by the reciprocal. So y prime equals 2x. I'm going to write that as 2x over 1 times y over 2y squared minus 2. So that gives me y prime equals 2xy. Remember, I'm trying to get, I want xy in my numerator, don't I? And I got it there. I got a 2, but it'll go away here soon. And I'm going to factor out a 2 and get y squared minus 1. And those are gone. And I've verified it. So this is simply substitution. You know, there's some calculus here. Here's my calculus, correct? That's the calculus. The rest of it is just algebra. Yes, ma'am.
Could you ever do the antiderivative of what the solution is? Like, instead of doing the derivative of y squared minus 2 ln y equals x squared, what if you did the antiderivative of xy over y squared minus 1?
And you could, but it's always harder to do the antiderivative than it is doing the derivative. There's nothing wrong with that, but that's a tough antiderivative to do. Okay. And I'm not saying we can't do it, because, you know, that's what we're doing where we're doing this separation by variables. I think in length of time, this might be the easiest way to go. Okay. So here's my problem. Okay. So this is an AP question. So the first part is, oh, it's going to ask me to verify. The B part won't be in there. That's just a question I ask you on the test to verify. So the first thing we're going to do is make the slope field. And do you see where I get this? That dy dx is equal to a negative y over x. Are you okay with that? All right, I just subtract the y and divided by x. I'm going to verify it here on the side in the margin. Actually, you want to do it your way, Riley?
Whatever's easiest.
I think that'll be okay. Okay, so we'll. Actually, I don't think it'll be okay. We're going to do it, but we're going to end up. I want to take the time to explain it at the end rather than here. Okay, so I'm going to say that x. Y prime is a negative y over x, because that's what I wrote right here, plus y. Well, what happens here? This is x over 1, right? They simplify. The x's are gone. I'm left with negative y plus y, and guess what? That equals 0. I don't think it gets easier than that. I think doing that substitution, Riley, is the easiest way to go. All right, so it's going to say, I got to make the slope field yet. So what can you tell me? Well, let's put a point in here. If I, at 1, 1, what kind of slope do I have? What would be my slope? Negative 1. So that's a negative 1. What can you tell me about 2, 2? Negative 1 also? What can you tell me about 3, 3? And 4, 4? What about negative 1, negative 1? It's still going to be a negative 1, because you can take the negative 1 and make it negative, and it becomes positive. Okay? So it's going to be the same diagonally here. What about at negative 1, 1? What do I have? Positive 1. And the same thing would hold true in the fourth quadrant. Okay? What about at 1, 2? What would I have? What would be my slope now? At 1, 2. Negative 2, right? So it's a little slantier. And this one's even more slanty. And that's even more slanty. They start to look in vertical, don't they? They get so slanty. And here would be the same thing. I'd have slope of negative 2. And then I'd get even slantier. Here I would have a positive 2, positive 3, positive 4. Here I'd have a positive 2, positive 3, positive 4. I've got symmetry going, don't I? What about at 2, 1, what would I have? Two comma 1. Negative 1/2. So that's a little flatter. A negative 1/3, even flatter. Negative 1/4, even flatter. Likewise here, I'd have a negative 1/2, negative 1/3, negative 1/4. I guess my drawing's not very good. Here I would have 1/2, 1/3, 1/4. are you seeing it says, can you draw 4 solution curves? Can you see that I have a solution curve right here? Can you see I have a solution curve right here? Can you see I have a solution curve right here? And right here. That's a hyperbola. Are we okay with that? We are now up to 3 points. So it says, this is, Riley, where I said it was going to take a little time. Okay? So I have dy dx is equal to a negative y over x. I'm going to rewrite this as 1 over y dy is equal to a negative 1 over x dx. Logan, okay, or you have a question? Okay. Now, the reason I keep the negative over here is I want y totally by itself. Sometimes you can't do it, but if you can, put it there by itself. And I'll show you some ones coming up where you won't be able to. Are we okay with this? All right, so if you can get to here, you're now up to 3 or 4 points on a 9-point problem. I'm going to compute the antiderivative. This, by the way, is the same as this. What's the antiderivative on this side? I always do the x side first. Anybody have an idea? What? Negative ln of what? X plus c. Yeah, I know I could call it C2, and the other one I can call C1, and I'll put them together, and I'll call them C. Okay, I already got it done. All right. What will I get over here? Natural log of y. 1 point for this, 1 point for that. You're now up to 4 or 5 points. Okay. Y is by itself, correct? Equals, what's my base? E. What's my exponent? Negative ln of x plus c. You get no points for that. You know, really? That was tough to do. Yes?
Because don't they have a base of e? So couldn't you set them equal to each other? Like both sides?
They are equal to each other.
Huh?
They are equal to each other.
No. All of those. Okay.
Oh, you're saying I could have these equal to each other.
Yeah.
Nah, the plus c is what screws it up.
Yeah.
Okay, that's why. I see what you're saying. Yeah.
Okay.
And a lot of people do that, say, hey, I could do this. Well, the thing is, it's that deal right there. So now, this means you have this. Correct? And to be honest with you, I usually jump to this right away. Is that us? No. Sometimes I have. One time I did that This is back in 2008. I was so in this one time, they just got up and walked out. I said, well, we'll see you tomorrow. And Mr. Martins was watching Mrs. Sorensen, evaluating her, because we get evaluated every 3 years. And he goes like this. My entire class got up and left like right now. And I walk out, and I'm going to go home. And Tyler Boone turns her out. They had all planned it. And they all started laughing and came back. And Mr. Martins is just in there shaking his head like, this guy is a complete moron. All right, are we okay here? And I just said that on the Abyss, so he can watch that and hear me. I told that story. What the heck? All righty. Are we okay here? This is a -1, isn't it? Right? That negative sign is a -1. That's the actual number, correct? So I can rewrite it like this. Y equals BE to the ln of 1 over x. Because that's x to the -1 power, isn't it? Are we okay that this -1 becomes the exponent of x as a -1, and I can write that as 1 over x? Remember, we're thinking this is the general solution, right? Right? So this -1 comes here as an exponent. That's 1 over x. So, on your calculators, I want you to do this. Tell me what e to the ln of 2 power is. Maybe some of you know already. It's 2. What's e ln of 3? 3. Why is that? Well, let's say I have e to the ln of 2. Well, that means the ln of, let's say I say that the ln of 2 is equal to, let's pick j for Jack. That means e to the j would equal 2, correct? Right? Well, I can replace the ln of 2 with e to the j. Why? Because that's what I said the ln of 2 was going to be. But guess what e to the j is? 2. In other words, an xe and ln are opposite inverses and cancel each other out, correct? I'll say it again. E and ln are opposite, they are inverses of each other and cancel each other out. That's the same thing as this. What if I said I got the ln of e to the 3rd power? What's that got to give me? Well, that's 3 times the ln of e, right? What's that going to be? 3. So, this e and this ln are going to do what? Get rid of each other. And y is going to equal b times 1 over x. Or y is equal to b over x. I use b. The directions use c. So now I want to go through this. It says, here's your condition. And I have y equals b over x. And I have the point 3 comma -1. So over here I'm going to have a -1. Here I'm going to have 3. Over here I'm going to have b. What's b got to be equal to? -3. So now my equation is y equals a -3 over x. Well, where is that? 3, -1 is right here. That's got to be my graph. go to my cell phone. Okay, was that our graph right here? Is that our graph?
No, but like when I turn it back, that's what my eyes are.
Isn't that our graph?
Yes. Wow.
Okay. Now, this was a little bit more intense, right? If you take a look, the very first one I had you do was dy dx equals 2x. Then the last time was the first time I introduced e to the x, right? It was, I think, one on the Slopefield activity, correct? Now we have one that's like this. So what we'll be doing problems is anywhere in between dy dx equals 2x to something like this. Again, this is only maybe the second or third time you've seen this. And so you'll get used to it. You'll see, oh, 1 over y, natural log. 1 over x, natural log. And slowly you'll get used to it. All right? Is it making more sense than the first time you saw it? Hopefully it does. Okay? This is, last year I think 97, 98% of the students, not everybody passed, but 97 to 98% of the students got a 6 or higher on that in my class on that question. That's really good. Okay, because you only have 2 and 4. You have 6 free response, I think. Okay, and you're trying to get half the points on each one if you can. That's what you're trying to do. Alrighty.